What would you say like the biggest challenges were like that you faced during your current research or research that you've done in the past, and just in general, was like the most difficult thing about what you do?
Success is a few and far between, but I have.
You have to motivate yourself every day. Like actually taking time to look after your mental health is really important in actually being able to do your PhD.
In order to actually get to the point where we can do the exciting work, like going on field trips or doing exciting experiments, we have to apply for money, we have to jump through certain paperwork, hoops, things that actually are quite tedious on the day-to-day. It's part of what gets us to the point of being able to do the more exciting stuff.
What would you say is like the most interesting thing that you've like found out from your research, like currently now? What is the most, the coolest thing, you've found out?
It's quite cool that space technologies are absolutely everywhere. And I didn't really think about it before my PhD, but we use them all the time. We're using it right now to communicate, because that's from telecommunication satellites, and internet comes from satellites. Mobile phones come from satellites, even like the food we eat. So agriculture, like that relies on Earth observation satellites. Or weather predictions about whether it's going to rain today relies on satellites. Everything relies on satellites. And I found that very cool because I hadn't really thought about that a lot before.
One thing in this frame that's quite interesting is this crater here, which I really excitingly got to name just very recently. So that was a big moment for me. I named this crater the Nairn crater. That's after Lady Carolina Nairn, who was a Scottish poet and songwriter who, in her lifetime, because she was a lady, was never allowed to publish under her own name because it wasn't thought of as being proper at that time. So it wasn't until after she died that one of her relatives published most of her work under her own name. And so now to have her represented on Mercury is quite special.
Often the places I go to are quite remote because I'm interested in cold processes. So we tend to go to the Arctic or high latitude cold environments that are quite remote. And these have access challenges. It's hard to get to these places. A good example is the Canadian high Arctic, which I went to in 2017, actually was the last time. And to get up there for our field deployment, we would be transported up there by these Twin Otter aircrafts. These are these small red planes that you might see in videos from things like the Antarctic as well. It's the same kind of aircraft. They transport scientists, teams of scientists around the Arctic. They can land, anywhere really. Anywhere you have a bit of flat ground, these things will land and take off. So this would fly us about 700 kilometers from our nearest point of civilization up into that high Arctic island I went to. And it's amazing, just that feeling of looking out the window of this aircraft and seeing the glaciers and the sea ice and just this completely wild environment out below you. And then, they drop you off, you unload all your gear, then the plane turns around and takes off and flies off south and just leaves you and your team isolated in this incredibly remote place.
So I spent 10 years working on building a machine to go to a comet and also to Mars to look for life on Mars. And that was called Beagle 2, and the comet mission was called Rosetta. So Rosetta was a great success. Sadly, Beagle didn't land safely, and so we didn't get any data back. But for the last 10 years, I've then been working, as I say, on translating the lessons we learned from building space machines into how could we then use that know-how back here on Earth.